Good morning. My name is Stefano Sorita, and today I will be presenting my final project for forecasting and time series. The title of my project is Forecast of Singapore CPI using Lasso. In this presentation, I will walk through the motivation behind the study, outline the models and methods I used, describe the data transformations, present my future results, and conclude the paper presentation. In the introduction, to begin, I have to say that accurate CPI forecasting are essential for monetary policy as they guide central banks' decisions. Singapore's open economy experienced influences from both domestic factors and international shocks, which makes forecasting particularly challenging due to the high number of potential predictors. The core research question I address is, can a lasso-based model which effectively manage dimensional data enhance one step ahead CPI forecast? In this investigation uses modern penalized regression techniques to select the most relevant predictors in automatically. The model and methods. In this study, I compare three forecasting approaches. The first model is a naive random walk model serving as a baseline. Then the second model is an ARIMA 101 that uses lag CPI changes to capture dynamics. And the third approach employs the lasso regression, which uses cross-validation to select the best subset of predictors in a large dataset. The three equations shown in the slide summarize these methods. First, the naive approach as that assumes a simple random walk. Then the ARIMA model that incorporates autoregressive and moving average components. And finally, the lasso model that adds a penalty term and this term shrink the less important coefficients towards zero. Then the data I use for this presentation, for this project, sorry, starts from January 1990 and ends in December of 2024. The primary variables include consumer price index, being the dependent variable, the exchange rate, oil prices, the Straits Times index, retail sales, industrial production, and the SPY index. The data are transformed by taking the logarithm to stabilize the variance, and then the difference are computed to approximate the inflation seasonal adjustment to ensure consistency in monthly observations. These steps prepare the forecasting analysis. Here, I also prepared divided the data in a train set and a test set. In the train set starts from 1990 up to 2010, and the test starts from 2010 to 2024. The results. Here are some forecasting evaluation for the results period presented from 2010 to 2024. In this table, we can see the mean squared forecasting error, and we can see that the Lasso model is a little bit better, it's 5% better than the other two models. Then we also see the mean squared fixed error ratio, that basically all are in the same range. And the Diebold-Mariano test, this one is closer to zero. Sorry. And finally, we can see with these results, we can see that there's a modest improvement in using the lasso approximation by reducing the roll error by 5.5% approximately compared to the baseline. While directional accuracy remains around 56% in all of the models, which is not the best predictor. The forecasting graphs. In these forecasting graphs, what I basically do is I try to present a comparison of how the predictors are working. So we can see in the naive random walk model, basically everything goes through a line and the predictions are not that good. And the ARIMA 101 and the lasso forecasting are trying to perform a little bit better. And in some peaks, the lasso model, you can see that performs in a better in a better way, and slightly smoother and potentially more adapted during periods of volatility. Then, just to conclude, the model slightly reduces the mean square forecast error by 5.5 relative to the naive benchmark with a borderline of DM test of 0.063 marginal significance. Although the directional accuracy is similar to across the model, the lasso approach demonstrates the advantage of automatically selecting pertinent predictors in a high-dimensional setting. For the future work, what I would try to do is expand the predictors and also try to use maybe an elastic net, or try also to maybe use factor models. Thank you very much for your attention.